To use logarithms to solve exponential equations, we will follow these steps. First, we will isolate the exponential expression. Second, we will take the common logarithm of both sides of the equation for base 10. We'll take the natural logarithm on both sides of the equation for bases other than 10. Now, you don't actually have to use natural log in particular situations, but for consistency, we're going to use natural log in each of those cases. Now, the third thing we'll do is simplify using one of the following properties. We have the power rule. Natural log of b to the x equals x natural log of b. Or natural log of e to the x equals x, in that case, as it arises. Or log, the common log, of 10 to the x equals x. And last, we will solve the resulting expression, or the resulting equation. Solve each equation below for x. We have 2 to the x equals 40. Now, one question that I need to ask myself is, can I write both sides of the equation to a common base? And the answer on this one is no. 40 isn't a power of 2. So I'm going to have to use logarithms. We use this tactic when we can't do anything else. So we'll take the natural log of both sides. Take the natural log of both sides. So that this is natural log of 2 to the x equals natural log of 40. Now we'll use our power rule to bring the exponent of x down as a coefficient. So this is equal to x times natural log of 2. And that equals natural log of 40. Now we can divide by natural log of 2 on both sides to arrive at x equals natural log of 40 divided by natural log of 2. Now, we're searching for an exact answer. If we needed an approximate answer, we could then evaluate that into a calculator or something of that sort. Our next equation is 5 to the x minus 7 equals 21. First, we want to isolate our exponential expression, so we'll add 7 to both sides. So we have 5 to the x equals 28. I'm going to space that out a little bit because my next move is going to be to take the natural log of both sides. So we have the natural log of 5 to the x equals the natural log of 28. Notice I like to put those in parentheses. I want to think of natural log as a function or log as a function. Now I can use my power rule to bring the exponent of x down as a coefficient. So I have x times natural log of 5 equals natural log of 28. And you want to start thinking of something like natural log of 5 as a number. It's just a multiplied number here, a factor. Now we can divide by natural log of 5 so that x equals natural log of 28 divided by natural log of 5. Again, that is our exact answer. For our next example, we have solve for x. We have 10 to the, we have a large exponent here, 10 to the x plus 1, that's our exponent, minus 8 equals 20. First thing we want to do is isolate the exponential expression, so we will add 8 to both sides. So that we have 10 to the x plus 1, again that's our whole exponent, equals 28. At this point, we want to take the log base 10 of both sides. And this is where I said you don't have to use log base 10, but it makes things work out fairly well, since our base of our exponential expression is 10. So that would be x plus 1 on the left-hand side, because the log of something with a base 10 is just going to result in the exponent. So x plus 1 equals log of 28. Now we'll subtract 1 from both sides. Now I cannot subtract 1 from the expression inside that is our argument inside of our logarithm. So this becomes x equals log of 28, and I'm going to close my parentheses there, minus 1. And that is my exact value. Now I haven't done this yet, but I really should be taking my values, my results for x, and putting them back in the original equation and seeing if they are indeed solutions. All of these we've had so far are solutions. I've checked these. For our next examples, we have solve each equation below for the specified variable. We have e to the negative t, it's our exponent, equals 0.04. Now, because I am looking at an exponential, a natural exponential, e to the negative t, I'm going to use the natural log. And we'll do this for any base that's not 10, but this works particularly well here. So that we have natural log of e to the negative t equals natural log of 0.04. The left-hand side would become minus t, because the natural log of e is going to result in the exponent, and that equals natural log of 0.04. Now we can divide by negative 1, since we had a negative t, to find that t equals negative natural log of 0.04. And that is our exact value. Again, you want to check that. All right, for our next example, we have 3e to the x minus 4 equals 11. So we'll isolate our exponential expression. We'll add 4 to both sides, so that we have 3e to the x equals 15. Now we have 3e to the x equals 15, so we'll divide by 3, so that we have e to the x equals 5. All right, now at this point, because we don't have a base 10, and also because this is a natural exponential, we want to use the natural logs. We'll take the natural log of both sides, so that we have natural log of e to the x equals natural log of 5. And natural log of e to the x is going to be x. So x equals natural log of 5. And that is our exact answer. Now for our last equation, we have 4 times 3 to the x plus 1. That's our exponent, x plus 1. Minus 5 equals 3. Let's isolate our exponential expression. We'll add 5 to both sides. So this becomes 4 times 3 to the quantity x plus 1 equals 8. Now because we have 4 as a coefficient, we're going to divide both sides by 4. So that this becomes 3 to the quantity x plus 1 equals 2. 8 divided by 4 is 2. Now, because we don't have a base of 10, we're going to use the natural log. So we have natural log of 3 to the quantity x plus 1 equals natural log of 2. Now we can bring our exponent down. Now our exponent is x plus 1. So I'm going to put that in parentheses so that I keep that factor together. So parentheses, x plus 1, close parentheses, times natural log of 3 equals natural log of 2. Now we can divide by natural log of 3 on both sides. So this becomes x plus 1 equals natural log of 2 over natural log of 3. My x is not isolated, so I'm going to subtract 1 from both sides so that my value for x, I have x equals natural log of 2 divided by natural log of 3 as one quotient minus 1. Not part of my fraction.